What's up, Science Nation? It's me, your boy Randall Deschler, coming straight from you from Jackson River's Governor's School. Now, you might be wondering, why is a guy like me in Jackson River Governor's School? Well, you see, I wanted to get my core classes out of the way, so when I got to college, I could get right into the good stuff. And today, I'm gonna be showing you how to calculate the circumference of the Earth using some shadows in a stick and your brain. Patented by Eratosthenes over 2,000 years ago. And let's jump right into it. But first, a word from our sponsors, Raid Measure the Shadow Legends. Okay, thank you, Randall. It is I, John Batman, from Raid Measure the Shadow Legends, Incorporated, and today I will be showing you how to use our patented book stacking technology to measure a shadow of a stick to find the circumference of the Earth. Now, a few things of note before we get started. Number one is, you're going to want to do these experiments around 1 o'clock in a sunny environment, because that is around when noon sun time is. Number two, you might want to do these at, around 5-10 minutes around 1 o'clock. Take about 10 measurements so we can get an average later. And make sure to do this on like 3 separate days so you just get all the good stuff. Now, I'm going to show you how to do this. Okay, so what you want to do with our patented technology is stack your books like so, and this usually works best. You might need a few heavier books if your stick is heavier, of course, and you want to set them up like so. Next, what you want to do is you want to take a measuring stick or measuring tape or anything like that, measure from the base of your stick to the end of your shadow. You want to do this around 10 times to get a good average, and you want to make sure this is as close to 1 o'clock as you can possibly get. And after this, you're done. You don't have to measure any more shadows or sticks. And next up, we just gotta do some math and a few quick measurements of some triangles, and that's about it. Okay, so the next step of our experiment, the math, or as I like to call it, the fun part. Not really, math's not fun. Anyways, the first thing you need is, of course, the measurement of your stick. Mine was 106.8 centimeters. Yours can be, any size you want. Bigger sticks usually work more because when you measure the shadow, there's less room for error. Okay, the next step is really simple. You just need 3 of your shadow measurements closest to 1 o'clock p.m. And then you average them together, because an average is usually more accurate than just, let's say, one of these measurements. And then next step is making your ratio. So let's say every 10 centimeters equals 1 centimeters. And using that ratio, you want to draw a triangle to scale of these 2 measurements. And then you just, draw your hypotenuse, just a straight line. It's really simple. And then using this scale triangle, you can measure that angle, which is the angle that the sun hits your stick. I got 40.92 degrees. And this will become really important in the next. So this next step is where things start getting tricky. The first thing you want to do is you want to find out what your latitude is. Mine is 37.81 north latitude. And with that, you need to find out how far you are away from the equator. And to do this, it's really simple. Since each degree of latitude equals 110.94 kilometers, you just multiply whatever your angle was by 110.94 kilometers, and that should give you how far you are from the equator. I'm 4,194.6 kilometers away. That's pretty far. And the next step is simple. It's just a ratio. All you need to do is put the part of your angle over the whole circle. So 40.92 over 360, and that equals 4,194.6, or whatever, how far you are away from the equator over the entire circumference of the Earth. And when you solve that simple algebra, you get 47,678.62 with my numbers, or whatever your numbers equal up, that is your circumference. Now let's see how Eratosthenes and I measure up. I got 47,678 kilometers. Eratosthenes got 40,000 kilometers flat. So I was about 19% off what Eratosthenes got. However, when Eratosthenes did this, he got 40,000 kilometers and The actual Earth's circumference, now measured using satellites, was 40,030 kilometers. So he was only 0.0074% off, which honestly is kind of crazy considering he did this 2,000 years ago when, we didn't even have trigonometry at this point. So he does deserve a lot of recognition for this.